There is a particular kind of quiet that belongs only to the late hours of the night, a quiet that isn't merely the absence of noise, but the presence of something deeper, a stillness thick with unanswered questions. It is the hour when the human brain loosens its grip on daytime certainties and dares to ask the questions it politely ignores when the sun is up. Questions like, where does everything end? What lies beyond the last star? Is there a cosmic shoreline where existence simply stops? And inevitably, a deeper, more unsettling question follows behind it like a shadow. What does it even mean for the universe to have an edge? It's an irresistibly human instinct to imagine the universe in terms we understand. We picture it as a colossal black auditorium with a back wall somewhere. Maybe cold metal, maybe crumbled stone, maybe an ancient cosmic border fence with a sign that whispers. Beyond this point, there is nothing. Or worse, no trespassing. But the universe does not care for our architectural metaphors. It was not built like a building, did not spread like a map unrolled across a cosmic table, and it certainly does not taper off into a cliff edge where galaxies tumble into void like careless tourists leaning too far over a railing. The universe is not a room. It is not even a place in the sense our minds desperately want it to be. And yet, the question persists. Where, then, is the edge? Pause for a moment. Lean into the silence. Let that question ring, not like an exam prompt, but like an echo in a cathedral. Let it expand. Let it haunt slightly. Because the first truth we must accept before we can even begin is that the edge of the universe is not where we think it is. It is not a wall. It is not a boundary line. It is not a cosmic fence post hammered into some final patch of reality. It is a consequence of physics, a consequence of light, a consequence of time itself. We are imprisoned not in cages of iron, but in cages of finite speed. Light, that crystalline ruler by which we measure reality, only moves so fast. It does not care how curious we are. It does not accelerate for our existential crises. It does not rush for our philosophical impatience. It trudges on at 299,792 kilometers per second, unwavering, uncompromising, and in doing so, it sketches the limits of everything we can ever experience. This gives us our first edge. Not the edge, but an edge. The observable universe, roughly a sphere centered on us, not because we are important, but because that's how observation works. Each being in the cosmos has their own bubble of visibility, their own horizon of knowable existence, carved out by the distance light has managed to cross since the universe first ignited itself awake. And here's the first surprise that always feels like a small existential thunderclap. This bubble is about 46 billion light years in every direction, vastly larger than the 13.8 billion years the universe has existed, a number that shouldn't make sense until it does. Because while light was moving, the universe was stretching like a canvas pulled wider and wider while paint is still drying. Space doesn't politely hold still while photons walk across it. It expands beneath their feet, dragging destinations farther away, like an escalator running backward under a sprinting child. So when we say this is the edge of what we can see, what we truly mean is this is as far as light has managed to reach us, despite space trying its absolute best to pull everything apart. Stand at that edge in your imagination. Look outward. Freeze the universe for a single impossible instant. In that frozen moment, yes, there is structure. Galaxies still swirl. Clusters still bind themselves into cosmic webs. Light still stretches itself into exhausted red whispers across impossible distances. But do not mistake this horizon as something you can ever travel to. It isn't a destination. It is a limit painted onto reality by time. This is not a wall. This is not the end of existence. This is simply the edge of knowledge. Beyond it, more universe. Probably. Almost certainly. Possibly infinite. Perhaps something else entirely. But it is not nothing. Not yet. And here we encounter an emotional truth we rarely articulate. The universe denies us absolute intimacy. We do not get to see it all. We do not get a master view. We are given this sphere of sight like a lantern in a fog, and beyond its luminous reach stretches endless possibility wrapped in untouchable darkness. This object we live inside, this glowing bubble of the observable, is deeply unfair in its generosity. It shows us just enough to inspire unbearable wonder, just enough to taunt us with its scale, just enough to whisper, "Look how much there is," and know that you will never see it all. And yet, part of the human condition is to stop and say, yes, but I will ask anyway. I will imagine anyway. I will science any question I please. Because this is our peculiar rebellion against cosmic indifference. We stare into the abyss, and instead of retreating, we start calculating, measuring, theorizing, writing poetry about physics. And somewhere inside that stubbornness lies something beautiful. The edge of the observable universe is not a defeat. It is an invitation. It says, here reality becomes story. Here science becomes philosophy. Here knowledge becomes faith and inquiry. So we stand at the edge of what we can see, and we ask, what lies beyond this shimmering boundary of light? Does the universe end? Does it loop? Does it curve back upon itself like an ancient mythological serpent swallowing its own tail? Or does it stretch forever, without shape, without edges, without mercy? The first answer is a strange one. We don't know, and more humbling still, we may never know. But tonight we dare to walk to that horizon in thought. Tonight, we loosen the bolts on reality and let imagination slip into step with astrophysics, not as fantasy, but as thoughtfully guided wonder. Because the edge of the universe is not a single question. It is 10,000 questions wrapped around a single heartbeat. It is a limit that forces us to confront what it means to exist at all. So let us continue. Slowly, deeply, with reverence, not racing toward answers, but savouring the mystery, like warm light spreading across the darkness. Because the universe is expanding, and so must our courage to think about it, there is something exquisitely, almost painfully human about standing on a shoreline and watching the ocean extend into a hazy nothing, that shimmering line where water blurs into sky. Not an edge, just a limit of sight, a horizon, a promise, a boundary that whispers beyond, me there is more, but refuses to say what. We stand there quietly, feeling a strange mixture of smallness and belonging, knowing we are looking at the limit of what our eyes allow. And beyond it lies a world still real, still roaring with waves we will never personally witness. Now imagine a horizon like that, but made not of water or sky, but of time and light themselves. A horizon so profound that it draws a line through reality between what we may someday know and what will forever exist, deaf to our presence. Tonight, we walk toward that second horizon. We left part one standing at the edge of the observable universe, a 4-6 billion light-year radius sphere, defined not by geography, but by how long light has had the chance to reach us since the cosmos first ignited. That horizon is vast, astonishing, humbling, and already strange enough, but the universe, as usual, is not done with us, because there is a difference, a deep, world-altering difference between what we can see and what we can ever touch. And it turns out that the second category is smaller, crueler, sharper, a little more heartbreaking. Let's begin gently. The universe is expanding. This is not metaphor. Space itself, not the galaxies moving through space like cars down a highway, but the highway itself, stretching and lengthening, is expanding everywhere, relentlessly, quietly, without sound and without pity. Every second, the fabric of reality swells. Galaxies do not drift apart like drifting boats. They are carried apart, like ink dots drawn away as a balloon inflates. And here is the crucial, devastating truth wrapped in cosmic elegance. Some galaxies are being carried away from us faster than light. Not because they are breaking the speed limit, nothing moves through space faster than light, but because space itself expands beneath them, like a treadmill accelerating beneath an exhausted runner. You sprint, you scream, you burn every drop of energy into forward motion, but the ground stretches backward faster than you can ever run. Light itself becomes that exhausted runner. It tries, it strains, it races toward us as faithfully and bravely as physics allows. And the universe simply says, no, the distance grows faster than light can cross it. There is a horizon that marks the dividing line between what light can ever reach us from and what is forever slipping away. This is not a poetic idea. It has a precise name. The cosmic event horizon, not the edge of what we see, but the edge of what we can ever influence, ever touch, ever share existence with in any meaningful physical sense. Right now, that horizon sits at roughly 16 billion light years away. Anything farther than that, even if we see it today, because earlier light managed to reach us, is already lost to us in the deepest, most existential way. There are galaxies now drifting into darkness, their final light still limping toward us like the last wave goodbye from a ship disappearing behind fog, but the ship itself is already gone. Even if we aim the perfect starship, the perfect communication beam, the loudest cosmic shout in the language of photons, it would never arrive. Those regions are receding faster than the message can travel. We are watching ghosts in slow motion. There is grief in that realization if you allow yourself to feel it, and maybe you should, maybe you must, because science is not only data and equations, it is also human meaning. There are entire galaxies, grand spiral masterpieces of gravity and light that will shine their last and collapse into darkness, and somewhere far beyond any horizon we can ever breach, no one will know they existed, but us here, briefly, in this fleeting cosmic moment. There are suns we will never feel the warmth of, planets whose storms we will never hear roar, civilizations that might exist and will never know we were ever here. There are children of distant galaxies who, if they look outward, will never see us, not even as ghosts. Our light will never reach them. And still, we pretend that the universe is accessible, that we can map it, tame it, conquer it, stretch our hands across it like gods of ambition. It sounds cold to say, but the cosmic event horizon is a boundary written in physics, so strict, so irreversible, that even time itself bows to it. This is not a border we can break with better rockets or braver astronauts. This is not a technological inconvenience. This is architecture. This is in the load-bearing structure of reality. Even at light speed, you will never reach that edge. And so we introduce two horizons, both beautiful, both terrifying, both deeply real. The particle horizon, the limit of what we can see, 46 billion light years. The event horizon, the limit of what we can ever touch or communicate with, to 16 billion light years. Everything beyond the latter is not simply distant. It is fading from our story forever. Now pause, just breathe, let that sink in. You may now ask, instinctively, rebelliously, beautifully, but what if we cheat? What if we do not play fair? What if we build warp drives, wormholes? What if we bend space-time, fold it like paper? Good. Ask it. Ask boldly. Science always begins with impolite curiosity. We can imagine warp bubbles, Alcubierre drives, shortcuts through the folds of space-time itself, and perhaps one day distant descendants of ours will learn to sculpt geometry itself like clay. Perhaps. But here is the haunting secret. Even if you could move faster than light, even if you broke every rule without tearing the universe apart in the process, you would not find a wall. You would not reach a cosmic curtain. You would not discover some majestic edge engraved with the end credits of existence. You would find more universe, more galaxies, more stretching space, more horizon, more same. Because if the universe is flat, and the best measurements whisper that it probably is, then it stretches, not merely big, not merely huge, but without edge. You would run forever and never circle back. You would go on without ever encountering a rim, a doorway, a frontier labelled final. It feels almost cruel, doesn't it? The universe offers us an edge that we can see, another edge we can never reach. And a possible third truth whispering, there may be no edge at all. And yet, doesn't that make it more beautiful? That we live in a universe where the limits are not cages, but invitations to humility? That we exist on a small rock, orbiting an indifferent star in a forgotten arm of a galaxy, drifting toward cosmic irrelevance, and yet we dare to think thoughts as large as horizons. We are a species that looks at a boundary written in the language of space-time itself and says, I'll think beyond it anyway. There is something heroic in that, something defiant, something profoundly human. So here we stand now, not on one shoreline, but two. One horizon shows us the last flicker of light the universe has allowed us to witness. The other shows us the last places the universe will ever allow us to touch. And standing between them, suspended in the expanding darkness, we must begin to wonder, if there is no edge in the way we want there to be, then what truly is the universe? A finite thing curled in upon itself? An infinite plane of existence stretching forever? Or something stranger still, something that demands geometry beyond intuition? That is where we must go next. And we will go slowly, deliberately, with awe, because to ask what happens at the edge of the universe is not merely to ask about space. It is to ask about destiny, about loneliness, about meaning, about how far reality extends before imagination must take the lead, and how far imagination dares to go. There is a strange unease that comes when you realise the universe might not simply be big, but structured in a way that laughs gently at the limits of human imagination. Size we can wrestle with. We can list numbers, we can count zeros, we can say 46 billion light years like we're ordering coffee. But shape is intimate. Shape implies design. Shape implies meaning. And tonight, we dare to ask, what shape is everything? Because whatever happens at the edge of the universe, whether there is an edge at all, depends not just on how far space stretches, but on how space is curved. And this is where the universe starts to behave less like real estate and more like philosophy. Let us stand in darkness for a moment. Not the dark of fear, nor the dark of loneliness, but the rich cathedral dark of deep thought. That velvet quiet where words fade and geometry takes over, where shapes become prayers. We look out into the universe and we do not merely see light, we see structure. Filaments of galaxies forming grand webs, curved paths of orbits carved by invisible gravity, light itself bending, deflecting, obeying rules etched into space-time like scriptures written at creation. Space-time curves. It curves because mass exists. It curves because gravity is geometry wearing a cloak of inevitability. If you have ever watched a marble roll across a stretched rubber sheet weighted down by a bowling ball, then you have witnessed a small parable of how reality organises itself. Not because the marble wants to curve, but because the surface beneath it demands it. The universe is not a stage where actors move. The universe is the stage. And the actors are simply following the choreography dictated by the floor beneath their feet. So now the question becomes, what is the shape of the stage itself? Is it flat? Is it curved inward? Curved outward? Is it finite? Is it infinite? Is it gently folded like silk? Or wrapped upon itself like some impossible knot? This is not abstraction. This is destiny. Because the universe's shape is not only a question of geometry, it is a question of fate. Three great possibilities. Cosmologists, armed with mathematics and humility, tell us that there are three great categories of cosmic geometry. 1, flat. 2, positively curved. 3, negatively curved. Let us walk through each slowly, reverently, as if touching the outlines of a god, the flat universe, the endless, edgeless plain. Imagine standing in the middle of a vast desert, so vast that no matter how far you walk, the horizon stays the same distance away. The ground does not curve upward, it does not fold, it just extends forever. No boundary, no loop, no walls waiting patiently at infinity, just continued isness. That is a flat universe. Not flat like a sheet of paper floating in some cosmic room, but flat in its internal geometry, meaning if you set two beams of light travelling side by side, they will stay parallel forever, never converge, never diverge, just go. In a flat universe, space is unbounded. There is no ultimate edge. Travel long enough and you do not return to where you began. You just continue. You move deeper into existence, finding more galaxies, more voids, more cosmic structures repeating like verses in an endless hymn. And our measurements, the astonishing precision of satellites like Planck and WMAP, whisper something extraordinary. The universe appears, to the limits we can measure, extremely close to flat. So close that, if it is curved, the curvature is so gentle that it escapes us. That alone should make the heart tremble a little. Because if it truly is flat, infinite in extent, then there may be no edge in any meaningful physical sense. The universe might simply go on. There is something beautifully terrifying about infinity. It is not simply large. It is not very big. It is fundamentally alien. It contains not only everything that exists, but potentially every configuration matter could take, given time and repetition. A flat, infinite universe is not just vast, it is generative. It ensures that somewhere unimaginably far away, configurations of reality could repeat. Not metaphorically, mathematically. But before we let that vertigo swallow us, let us step gently into another possibility. The positively curved universe, the loop of everything. There is a different kind of beauty, quieter, more intimate, more complete in imagining a universe that curves back on itself. Not flat, not infinite in reach, but finite while still having no edge. A cosmic mirror of a far more familiar truth. You can walk around the Earth forever without falling off. Not because Earth ends in a cliff edge, but because it bends. Now imagine this in 3 spatial dimensions instead of 2. A positively curved universe would be a kind of hypersphere. You could travel in a straight line forever and eventually return to where you began, not because you looped around something external, but because space itself closed back upon itself. Finite, but boundless, limited, yet edgeless, complete. There is a deep, poetic satisfaction in that. It appeals to something in us that loves stories that return to their beginnings, symphonies whose final notes echo the first. A universe like that feels self-contained, like a cosmic sentence that ends with itself. If space is positively curved, then in a sense, the edge of the universe is everywhere. There is no outside, there is no beyond. There is only inside, eternal, looping back upon itself in endless recurrence. You could chase the horizon forever and eventually emerge behind yourself, beautifully futile, cosmically comic. But this requires something physics does not easily give. Enough mass, enough density, enough gravitational pull to curve everything back inward. And our measurements suggest probably not. But probably is a long way from certain. We have not measured curvature with infinite precision. We cannot. The cosmos hides its true geometry behind horizons, behind uncertainty, behind the quiet cruelty of finite data in an infinite question. So we remain humbly suspended between possibilities. The negatively curved universe, the hyperbolic cathedral. The third possibility is stranger still. A negatively curved universe would be like a vast, infinite saddle, every direction bending away from every other. Lines that start parallel would diverge forever, like 2 friends walking together who are doomed to drift apart no matter how desperately they try to stay aligned. This universe expands aggressively. This universe never thinks about looping. This universe is born to run. A hyperbolic universe feels colder, lonelier, sharper. It implies a future where everything races away from everything else, where gravitational binding loses its argument against relentless expansion, where isolation is not only fate but geometry. And yet, it too has beauty, a fierce beauty, the beauty of unstoppable momentum. So which do we live in? We don't know. And more profoundly, we know that we don't know. We measure, we calculate, we peer into microwave background radiation like mystics reading the last embers of creation. We whisper, it seems flat, almost perfectly flat, maybe exactly flat, but almost matters, maybe matters, because to declare with certainty that the universe is infinite is to make a claim so enormous that it demands infinite confidence. And science does not deal in absolutes lightly. So we stand on a knife edge between a universe that might be eternal and infinite and a universe that might secretly be gently curving back in upon itself, waiting patiently to be discovered for what it truly is. And here is the humility we must accept. We may never know, because any curvature might occur on scales so large that no being inside the universe, limited by horizons and lifetimes and light speed, could ever measure it. There may be truths about existence that no intelligence, however advanced, can ever uncover, not because we are not clever enough, but because reality simply does not permit the experiment. And yet, we ask anyway, because that is what we do. So what, then, of the edge? In a flat universe, there is no edge. In a positively curved universe, there is no edge. In a negatively curved universe, still no edge. The universe seems determined to deny us cliff faces and endings. It offers us instead curves and infinities and inexhaustible continuation. The edge dissolves into a horizon of understanding, one that constantly retreats as our imagination steps forward. And yet the story is not finished, not even close, because shape is only part of the truth. There is a deeper question lurking beneath geometry, a stranger, bolder speculation that humanity now dares to whisper into the dark. What if our universe is not the only universe? What if the ultimate edge is not the edge of space, but the edge of our bubble of reality itself? That question waits for us in the distance, pulsing gently like a lighthouse at the far edge of thought. But before we get there, we must first accept this. The universe is not obligated to give us comfort. It is not required to be simple, intuitive, or kind. And yet, it gives us enough beauty to keep asking, enough mystery to keep wondering, enough openness to keep walking toward horizons, knowing full well we will never reach them. The observable universe, a horizon made of light, time, and the slow fading of certainty. If the universe has an edge, we have never seen it. What we have seen instead is something far more unsettling, a limit that moves with us, expands with us, and yet never recedes far enough to reveal what lies beyond. This limit is called the observable universe. It sounds technical, clinical, almost modest, but hidden inside the phrase is one of the most profound ideas science has ever produced, that reality is larger than what reality allows us to know. Light is the currency of knowledge. Every star you see, every galaxy captured by a telescope, every faint smudge at the edge of an image is not a thing as it is now, but a message sent long ago. Light takes time to travel. Even at its impossible speed, it is never instantaneous. When you look at the sun, you see it as it was 8 minutes ago. When you look at the nearest stars, you see decades into the past. When you look at distant galaxies, you are staring billions of years backward into eras when Earth did not yet exist. Astronomy is not observation. It is archaeology conducted at the speed of light. The universe is about 13.8 billion years old. That number sets a hard boundary. No light from farther away than 13.8 billion light years in light travel time can have reached us, because there has not been enough time since the beginning for it to do so. This seems straightforward, but space complicates everything. Space itself is expanding. So while the light from a distant galaxy has been travelling for 13 billion years, the galaxy itself is now much farther away than 13 billion light years. In fact, the radius of the observable universe today is about 46 billion light years. This is the first quiet shock. The observable universe is larger than the universe's age would suggest, because space has stretched while the light was en route. We do not live inside a static bubble. We live inside a balloon that has been inflating since the beginning of time. The observable universe is not centered on Earth. It cannot be. Every observer, anywhere, has their own observable universe, a sphere, defined by how far light has had time to reach them. Move to a galaxy 10 billion light years away, and your observable universe shifts with you, revealing regions forever hidden from us while concealing regions we can see. There is no universal map, only local horizons. This dismantles the idea of a cosmic edge in a deeply personal way. If the universe had a physical boundary, some ultimate wall or termination, then observers in different places would see different distances to that edge. But what we see instead is symmetry. No matter where you stand, the universe appears roughly the same in all directions. This is not coincidence. It is the universe refusing to give us a frame of reference. The observable universe is not a border you can approach. It is a condition you inhabit. No matter how fast you travel, no matter how advanced your technology becomes, the horizon remains fixed relative to you. Galaxies at the edge recede faster than light, not because they are moving through space too quickly, but because space itself is stretching between you and them. This is one of the most counterintuitive truths in cosmology. Nothing violates the speed of light, and yet things can become unreachable forever. There are galaxies whose light reaches us today for the last time right now, because from this moment onward, the expansion of space will outpace that light forever. Their future is already sealed into invisibility. The observable universe is not just a boundary of distance. It is a boundary of time's generosity. There is something deeply poetic and unsettling about this. The universe is not revealing itself fully, it is revealing itself temporarily. We live in a brief era when the cosmos is visible at all. Billions of years from now, accelerated expansion will have carried most galaxies beyond the observable horizon. Future astronomers, if any exist, will see a lonely universe, a single galaxy in darkness, surrounded by empty sky. They may never know the universe was once crowded. Cosmic knowledge is perishable. This reframes the question of the edge in a subtle way. We often imagine the edge as something spatial, something you could, in principle, reach. But the observable universe suggests a different metaphor. Reality is not fenced. It is fading. Not everywhere at once, but gradually, asymmetrically, with regions slipping out of causal contact like memories you can no longer retrieve. The universe is not hiding its edge from us. It is letting parts of itself go. And yet, beyond the observable horizon, physics gives us no reason to believe there is anything special. No wall, no void, no abrupt change in laws. The same patterns likely continue. Galaxies, voids, dark matter scaffolding, cosmic microwave background cooling, ever further. Beyond the horizon is not chaos. It is more of the same, but forever inaccessible. This may be the most unsettling idea of all. That reality extends beyond us, not in mystery, but in banality. An infinite repetition we will never confirm. But there is another twist. The observable universe is not only limited by time and expansion, it is also shaped by our position in cosmic history. Early in the universe, everything was closer together. Light had less distance to travel. In the far future, expansion will isolate everything. We exist at a privileged moment, not because we are special, but because the universe is young enough to be legible. This is not destiny, it is timing. We ask about the edge because we arrived when asking still makes sense. And this raises an uncomfortable thought. If the observable universe is all we can ever interact with, does what lies beyond matter? From a strict physical standpoint, perhaps not. If no signal can ever cross that boundary, then beyond it is causally irrelevant to us. It cannot affect our past, present, or future. But relevance is not the same as existence. A book unread still exists. A star unseen still burns. A region beyond our horizon still unfolds its own history, indifferent to our ignorance. The universe is not obligated to be meaningful to us in its entirety. This is where the idea of an edge dissolves further. There is no cliff where space drops into nothingness. There is only a gradient from the known to the unknowable, from the illuminated to the forever dark. The edge of the universe is not a place, it is a limit of causation, a boundary not of matter, but of relationship. And this boundary is not static. As the universe expands faster and faster, the observable region shrinks in relative terms. Fewer galaxies remain connected, fewer futures remain shared. The universe is becoming more isolated over time. Not colder yet, not empty yet, but lonelier. If this sounds bleak, it is only because we are still thinking in terms of loss. But perhaps the correct response is gratitude. We live at a moment when the universe can still be seen as a whole, when its story is still readable across billions of light years, when questions about edges feel urgent rather than irrelevant. The observable universe is not a prison, it is a gift. Still, one question lingers. If every observer sees themselves at the center of their own horizon, if the universe looks roughly the same in every direction, if no edge presents itself, no matter where you stand, then what does center even mean? And if there is no center, what exactly is expanding? Expansion and the illusion of center. Why every observer thinks they're in the middle and why none of them are. There is a moment early in every child's understanding of the world when they realize something unsettling. The world does not revolve around them. Before that realization, everything seems centered, literally. You look out from your eyes and the world arranges itself around your body. Left and right, near and far, above and below, all coordinates radiate outward from where you stand. It feels natural. I am here. Everything else is elsewhere. That instinct never fully leaves us. So when we imagine the universe expanding, we picture something familiar. A center point, an explosion, matter rushing outward into pre-existing space, a cosmic fireball with a definable origin and a direction of growth. This picture is wrong. And understanding why requires letting go of one of the most comforting ideas we have, that the universe has a place where it started, and that we might, in principle, point to it. The universe did not explode into space. Space itself expanded. This distinction sounds semantic until you follow it to its conclusion. If space itself is stretching, then every point moves away from every other point. There is no central location where expansion began. No cosmic scar mark in the origin. The Big Bang was not a detonation at a point, it was a state that existed everywhere at once. Every region was once closer to every other region. Everywhere was the beginning. This is not intuitive. It violates the way we understand motion, growth, and causality. But the mathematics is unambiguous. When astronomers observe distant galaxies receding from us, they are not witnessing motion through space. They are witnessing space itself expanding between objects. And here's the unsettling part. If you lived in a distant galaxy, you would see the same thing. Galaxies would be rushing away from you in all directions. The farther they are, the faster they appear to recede. From your perspective, you would seem to be at the center. Everyone gets to feel central. No one actually is. This is the illusion of center. The universe grants every observer the same experience. A horizon surrounding them, expansion radiating outward, symmetry in every direction. It feels like privilege. It feels like importance. It is neither. It is geometry. To make sense of this, Cosmologists reach for metaphors, not because metaphors are accurate, but because they are survivable. Imagine the surface of a balloon with dots drawn on it. As the balloon inflates, the dots move farther apart. From the perspective of any dot, all other dots are receding. No dot occupies the center of the surface, because the center exists in a higher dimension, not on the surface itself. The surface has no edge and no center. The universe may be similar, not embedded in a larger space we can point to, but self-contained, expanding internally with no external reference frame. We ask, what is the universe expanding into? And the honest answer is, the question may not apply. This is where intuition breaks. Because we are creatures who live inside containers, rooms, valleys, atmospheres, oceans. Every expansion we've ever witnessed happened into something else, but the universe may be the totality of something. There is no outside waiting, no cosmic room beyond the walls. Expansion does not require a destination. It only requires change. Once you accept this, the idea of an edge becomes even stranger. Edges separate inside from outside. But if there is no outside, if space itself is all there is, then what would an edge even mean? An edge of what? And compared to what? The universe does not appear to end where it meets something else. It simply continues, or curves, or repeats, or does something our language cannot yet hold. The illusion of center also infects our sense of scale. We talk about the size of the universe as if it were a measurable object, like a mountain or a city. But if the universe is infinite, it has no size in the conventional sense. If it is finite but unbounded, its size exists mathematically but not experientially. You cannot walk to the edge of a sphere's surface. You can only keep walking. The universe may be doing the same thing, only in more dimensions than we can visualize. And then there is the most unsettling implication of all. If there is no center, then there is no privileged viewpoint, no cosmic balcony, no place where the universe reveals itself in full. Every observer is confined to their horizon. Every perspective is partial. The universe cannot be seen from the outside because there is no outside to stand in. This means the universe is fundamentally unobjectifiable. It cannot be fully pictured. It cannot be fully grasped. It must be inferred, pieced together from fragments of light and mathematics, stitched into coherence by minds that evolved to count fruit and avoid predators. This is not a failure of intelligence. It is a mismatch of scale. The expansion of the universe teaches us something uncomfortable about ourselves. We keep asking where the center is because we want reassurance that there is a vantage point from which everything makes sense, a place where confusion resolves, where the full pattern is visible. But the universe does not offer that comfort. It offers only local meaning. Understanding must be assembled without ever seeing the whole. And yet despite this, the laws of physics appear consistent everywhere we can see. The same constants, the same behaviors, the same patterns, repeating across billions of light years. This uniformity is not guaranteed. It is discovered, and it raises a quiet question. If the universe looks the same everywhere, if there is no center, if no location is special, then perhaps the idea of an edge is not about space at all. Perhaps it is about limits, limits of measurement, limits of inference, limits of language. Perhaps the edge of the universe is not where space stops, but where explanation does. There are places where our theories falter, where gravity and quantum mechanics refuse to cooperate, where space-time curves too violently for equations to behave, where infinities appear, signaling that something fundamental is missing. These may be the true edges, Not walls in space, but fractures in understanding. And this brings us closer to the heart of the matter. When we ask about the edge of the universe, we may not be asking about where. We may be asking about how far our theories can reach, how far observation can stretch, how far human cognition can travel before it dissolves into metaphor. The universe expands, our understanding chases it, and somewhere ahead, always ahead, there is a boundary not of stars, but of sense. In the next part, we will step beyond the observable horizon, not physically, but conceptually. We will ask what lies beyond what can ever be seen, and whether that question has meaning at all. Because the most unsettling possibility is not that something strange exists beyond the edge, but that nothing changes. What lies beyond the horizon? Not emptiness, but ignorance. There is a particular fear that arises when you realize something is not hidden from you, but unreachable. A locked door invites curiosity. A sealed box invites speculation. But a horizon that recedes, no matter how fast you move, invites something else entirely. Resignation. The cosmic horizon is not a veil waiting to be lifted. It is not a puzzle box with a clever mechanism. It is a boundary enforced by the structure of space-time itself, a limit beyond which information cannot flow to us, now or ever. When we ask what lies beyond it, we are not asking a question the universe is obligated to answer. The instinctive response is to imagine nothing, an abrupt termination, a thinning of reality, a cosmic edge where galaxies stop appearing and space dissolves into silence. But this instinct is inherited from Earth, from cliffs and coastlines and walls. It assumes that absence follows presence, that beyond every something, there is eventually nothing. Cosmology offers no support for this picture. In fact, it suggests the opposite. Beyond the observable horizon, the universe likely continues much as it does here. Galaxies forming, stars burning, matter clustering along invisible filaments of dark matter. Physics does not predict a sudden change in behavior simply because light cannot reach us. The universe does not respect our visibility. It is not built around observation. What lies beyond the horizon is not emptiness. It is causal disconnection, a region that exists without relationship to us. This distinction matters because emptiness is a property of space. Ignorance is a property of observers. When we reach the horizon of the observable universe, we do not encounter a feature of reality, we encounter a feature of ourselves. There is something deeply unsettling about this. Human curiosity is directional. It moves outward, seeking novelty, explanation, completion. We are comfortable with unknowns that promise eventual resolution, but the cosmic horizon offers no such promise. No mission can cross it. No signal can return from it. No experiment can probe it indirectly. Beyond the horizon, reality becomes theoretically plausible, but empirically inaccessible. This is a new category of ignorance, not temporary, not technological, but fundamental, and yet physics does not remain silent. It continues speaking carefully, probabilistically, about what might lie beyond. The most conservative assumption is sameness. The cosmological principle suggests that the universe, on large scales, is homogeneous and isotropic, the same everywhere, the same in every direction, no preferred regions, no cosmic landmarks. If this principle holds beyond the horizon, then there is nothing special waiting out there, just more universe. This is, in a way, the least comforting possibility. It denies drama. It denies revelation. It denies the fantasy that the edge hides something extraordinary. Instead, it offers endless repetition structures, like ours, perhaps infinitely many times over, unfolding beyond our reach. But repetition carries its own strangeness. In an infinite universe governed by finite physical laws, patterns must recur. Not metaphorically, literally. There may be regions where galaxies align just as they do here, where stars form in similar spirals, where planets orbit suns like ours, where chemistry repeats its experiment, where life, given enough time and space, emerges again. And if life emerges again, then consciousness might too. Versions of us, not identical in detail, but familiar in outline, asking similar questions under skies they will never leave. This idea is not science fiction. It is a logical consequence of infinity, and it is quietly terrifying. But infinity is not guaranteed. The universe may be finite, yet unbounded, curved in ways that allow it to loop back on itself without edges. In such a universe, travelling far enough in one direction might eventually bring you back, not to where you started, but to a region causally connected in unexpected ways. Even here, there is no edge, only topology, only shape. The universe would be complete without being enclosed. And then there are the wilder possibilities. Inflationary cosmology suggests that our observable universe may be just one bubble in a vast, ever-expanding multiverse. Other regions may have broken off during inflation, forming their own universes with their own physical constants, their own laws, their own outcomes. Beyond our horizon, reality may not merely repeat, it may diverge. Different strengths of gravity, different particle families, different dimensional structures, universes where atoms never form, universes where stars burn too quickly, universes where complexity never gains a foothold. In this view, what lies beyond the horizon is not more of the same, but an unbridgeable plurality. We would not be isolated in an empty cosmos. We would be isolated in a crowded one, but here, caution is required. These ideas, while mathematically motivated, sit at the edge of testability. They may be true, they may not, and the universe offers no easy way to decide. This is the price of asking questions at cosmic scale. Eventually, explanation outruns verification, and science disciplined, careful science slows down, not because it has failed, but because it refuses to pretend. This brings us to a philosophical turning point. If what lies beyond the horizon cannot affect us, cannot be observed, cannot be tested, does it matter? Physically, perhaps not, but existentially, very much so, because it reframes our relationship with reality. It tells us that the universe is not organized around what can be known, that existence is not contingent on being witnessed, that meaning is not automatically aligned with measurability. The universe does not perform for us, it simply unfolds. There is humility in this realization. The edge of the universe is not a cliff, it is a reminder that knowledge has structure, that understanding arrives bounded, that some questions are not answered by progress, but by acceptance. This does not make inquiry futile, it makes it honest. And yet, we are not done. Because even if space continues endlessly beyond the horizon, even if universes multiply beyond reach, even if reality extends without boundary, there may still be another kind of edge, not spatial, not causal, but temporal, an edge not of where, but of when. The universe does not only expand in space, it moves through time, and time too may have limits. In the next part, we will turn from space to shape, from horizons to curvature, from distance to geometry. We will ask whether the universe is infinite, finite, or something that refuses both categories. Because sometimes the deepest edges are not places you approach, but structures you inhabit without realizing. Infinity, finite space, and curved reality. The universe that loops without edges. There is a particular kind of relief that comes from imagining an edge. An edge means completion. It means a place where questions stop. It means a boundary where the unknown becomes at least well-defined. Infinity offers no such comfort. It is not dramatic. It does not announce itself. It simply refuses to end. And yet, when physicists talk about the shape of the universe, infinity is often the simplest answer. Not because it is satisfying, but because nothing we observe rules it out. At first, infinity sounds extravagant, excessive. Surely reality must be economical. Surely there must be a finite amount of space, a cosmic inventory that can, in principle, be counted. But nature has never promised thrift. When astronomers measure the geometry of the universe, they are not measuring size directly. They are measuring curvature, how space behaves on the largest scales. Flat space continues forever. Positively curved space eventually loops back on itself. Negatively curved space expands endlessly, faster than Euclidean intuition allows. So far, every measurement suggests something unsettlingly mundane. The universe appears flat. Not approximately flat, not mostly flat, flat to the limits of our instruments, which means one of two things. Either the universe is infinite, or it is finite but so vast that its curvature is undetectable within our observable horizon. Both possibilities are equally disturbing. A finite universe without edges sounds like a paradox until you abandon the idea that edges are required. Consider the surface of a sphere. Finite area, no boundaries, no place where the surface ends and something else begins. You can travel indefinitely without ever encountering an edge, and yet the surface is not infinite. Now remove one dimension. Imagine the universe as a three-dimensional analogue of that surface, not embedded in a higher dimensional space you can point to, but self-contained, closed, and unbounded. In such a universe, asking what lies beyond the edge is like asking what lies beyond the surface of Earth. The question assumes a direction that does not exist. This is where geometry becomes philosophy. Because curved space does not feel curved locally. Walk across Earth and it feels flat. Build cities. Draw straight lines. Only when you zoom out, only when you look globally, does curvature reveal itself. The universe may be doing the same thing. Locally flat. Globally closed. A cosmos that loops, not visibly, but mathematically. And yet, despite decades of increasingly precise measurements, we cannot tell. The observable universe is simply too small a patch of the whole. This is one of the great ironies of cosmology. We can measure the temperature of the cosmic microwave background to 1 part in 100,000. We can infer the distribution of dark matter across billions of light years. We can trace the history of expansion back nearly to the beginning of time. But we cannot tell whether the universe ever ends. Our ignorance is not due to carelessness, it is due to scale. If the universe is infinite, then it contains an uncountable number of galaxies. Not metaphorically uncountable, literally endless. This does something strange to meaning. In an infinite universe, every physically allowed event happens not once, but infinitely many times. Every configuration of particles that can occur does occur somewhere an infinite number of times. There are regions where stars never form, regions where galaxies collapse early, regions where life emerges briefly and vanishes, regions where civilizations rise and fall without ever knowing they were not alone. And yes, regions arbitrarily similar to ours, not because the universe is creative, but because infinity is exhaustive. This idea unsettles us because it collides with our sense of uniqueness. If everything happens somewhere, what does it mean that it happens here? If versions of us exist elsewhere, differing by microscopic contingencies, does individuality dissolve into statistics? Physics does not answer these questions. It simply presents the implication and moves on. Meaning is not its department. A finite universe avoids this particular discomfort. If space is limited, then events are not repeated endlessly. The universe has a total inventory of matter, energy, and possible histories. There are limits to variation, finality exists, but finite universes introduce their own unease. Because if space is finite and unbounded, then the universe is complete, not open-ended, not endlessly surprising, complete. And completeness feels like stagnation when applied to existence itself. There is another subtle tension here. Infinity is easy to write into equations. Finite but unbounded spaces require specific initial conditions, just the right curvature, just the right balance between expansion and density. These conditions may exist, but they feel tuned, and tuning raises suspicion. Physicists are wary of special pleading. The universe does not like fine print. Yet nature has surprised us before. Dark energy, the mysterious force accelerating expansion, was not predicted. It arrived unannounced, altering the fate of the cosmos without asking permission from theory. The universe does not seem obligated to prefer simplicity. It prefers consistency. This brings us to a quieter realization. Whether the universe is infinite or finite may not matter in the way we think. Both erase the idea of an edge. Both deny us a final location where curiosity can rest. Both imply that what happens at the edge is the wrong framing entirely. The universe is not a container. It is a condition, and here something important shifts. The edge stops being spatial. It becomes conceptual. The true boundary may lie not in the structure of space, but in the structure of explanation. We are comfortable imagining curved surfaces. We are less comfortable imagining explanations that never terminate. An infinite universe has no final reason. A finite universe has no external cause. In both cases, the chain of why eventually reaches a point where language fails. This is not a flaw. It is a horizon of comprehension. And horizons, as we've seen, do not mark endings. They mark transitions from knowing to not knowing, from certainty to humility. Perhaps the universe loops. Perhaps it stretches forever. Perhaps both descriptions are shadows of a deeper reality we do not yet possess the mathematics to articulate. What matters is this: no version of the universe grants us an edge where mystery resolves into silence. Mystery persists. And now, as space bends and refuses to finish, another idea begins to intrude, one even more disorienting. What if our universe is not alone? What if the absence of an edge is not because space is infinite, but because reality itself comes in plural? In the next part, we will step into that unsettling possibility. Not gently. Multiverse whispers, bubble universes, cosmic isolation, and the fracturing of reality. There is a moment in every serious inquiry when the questions stop scaling gently. They leap. They leave the terrain of refinement and enter something stranger, where answers are no longer extensions of what we know, but alternatives to it. The multiverse is one of those leaps, not because it is exotic, not because it is speculative, But because it quietly dismantles the assumption, we almost never question that reality comes in one piece. For most of human history, the universe was singular by necessity. There was no observational reason to imagine otherwise. One sky, one cosmos, one set of rules. Even when we learned that the Milky Way was not the whole story, we simply expanded the definition. The universe grew larger, but it remained one. The multiverse challenges that unity. It suggests that what we call the universe may be a local event, a region, a bubble, a phase, embedded in something far larger, far stranger, and fundamentally unreachable, not beyond the horizon, beyond this reality. The idea does not come from mysticism. It arises reluctantly, almost defensively, from physics itself. Inflation theory, the idea that the universe underwent a brief but violent exponential expansion shortly after the Big Bang, solves multiple problems at once. It explains why the universe appears flat, why distant regions look similar, why small quantum fluctuations grew into galaxies. But inflation has a side effect. It does not end everywhere at once. In many versions of the theory, inflation continues eternally, spawning isolated pockets where it slows down, condenses, cools, forming universes like ours. Each pocket is a bubble universe. Each bubble is causally disconnected from the others. They do not collide, they do not communicate, they do not share information, they simply exist. If this picture is correct, then our observable universe is not the whole of reality. It is an island, not floating in space, but embedded in a higher level process we cannot step outside to observe. The edge of our universe, in this context, is not a boundary of space. It is a boundary of phase. Beyond it, space-time itself may take on different forms, or not exist at all in any familiar sense. This reframes the question in a startling way. What happens at the edge of the universe? Perhaps nothing happens. Perhaps edges are not events. Perhaps they are transitions without witnesses. The multiverse also offers a possible answer to a question that has haunted physics quietly for decades. Why do the laws of nature have the values they do? Why is gravity so weak compared to electromagnetism? Why do fundamental constants fall into narrow ranges that allow atoms, chemistry, stars, and life? Why does the universe seem delicately balanced on the knife edge between chaos and sterility? In a single universe picture, these questions feel urgent, almost accusatory. In a multiverse, they dissolve. If there are countless universes with different physical constants, then we should not be surprised to find ourselves in one where conditions allow observers, not because it is special, but because only such universes can ask the question. This is not design, it is selection. The universe we inhabit may be statistically rare, but observationally inevitable. This idea is unsettling because it shifts explanation from cause to context. The universe is not this way because it had to be. It is this way because we are here to notice it. Many physicists resist this conclusion, not because it is illogical, but because it feels unsatisfying. It trades mechanism for circumstance. It replaces inevitability with contingency. It feels like giving up, but perhaps it is simply letting go of an expectation that reality owes us elegance. Still, the multiverse presents a profound challenge. It may be fundamentally untestable. No signal can cross from one universe to another. No experiment can probe beyond our bubble. No observation can confirm or deny the existence of others directly. This makes the multiverse deeply controversial. Some argue that ideas without testable predictions fall outside science. Others argue that if a theory explains what we see and arises naturally from well-tested frameworks, then unobservability is not disqualification, it is consequence. The universe does not guarantee accessibility. And yet, even if the multiverse exists, it does not give us the edge we were hoping for. It simply moves the question outward. What is the structure that contains these universes? Does it have limits? Does it end? Does it exist in time, or is time local to each bubble? The multiverse does not end the conversation. It multiplies it. There is something profoundly humbling about this. We began by asking about the edge of the universe, imagining a line we might one day approach. Now we are faced with the possibility that reality has no single edge, only nested layers of existence, each with its own horizons, each unreachable from within. We may be inhabitants of a reality that is, by construction, incomplete. And perhaps this is the quiet truth the multiverse whispers: that completeness is not the natural state of understanding. That being embedded means never seeing the whole, that the universe or multiverse is not meant to be grasped in totality, only inhabited locally. But there is still one dimension we have not confronted directly: time. Space may stretch endlessly. Universes may multiply. Edges may dissolve into abstraction. But time moves relentlessly, and it may have its own boundary. Not at the beginning, but at the end. In the next part, we turn from the question of where reality might end to the question of when. Because even if space has no edge, time might heat death and the fading edge of time. When the universe does not end in fire or collapse, but in silence, if the universe has an edge, perhaps it is not a place you travel to. Perhaps it is a moment you wait for. Not an instant of violence, not an explosion, not a final collapse inward, but a gradual loss of difference. A future so quiet it barely qualifies as an event at all. Human imagination favours dramatic endings. We expect universes to end the way stories do, with tension, release, punctuation, a fireball, a crunch, a last decisive transformation where something happens. The universe seems uninterested in this narrative instinct. According to everything we understand about thermodynamics and cosmology, the most likely fate of the universe is not annihilation. It is dissolution. Not into nothingness, but into sameness. Entropy is the silent protagonist of this story. It is not destruction. It is not decay in the moral sense. It is the tendency of systems to move toward equilibrium, to erase gradients, smooth contrasts, eliminate opportunities for work. Life depends on imbalance. Stars burn because there is a difference between hot and cold. Planets orbit because energy is not evenly distributed. Thought itself exists because there are differences between states, between possibilities. Entropy erodes those differences patiently. In the far future, stars will exhaust their fuel. Not all at once, one by one. The most massive burnout first, collapsing into black holes or neutron stars. Smaller stars linger longer, glowing faintly for trillions of years. Eventually, even they fade. Galaxies darken. The night sky empties, but still time continues. Planets drift cold and silent around stellar remnants, chemical reactions slow, structures fracture under quantum effects and cosmic rays, matter itself begins to unravel. Black holes remain the last engines of order, swallowing energy, preserving gradients. But even they are not eternal. Through a process known as Hawking radiation, black holes leak energy, imperceptibly at first. Then, over spans of time so vast, they dwarf all of cosmic history so far, they evaporate. What remains is thin, diffuse, almost nothing, but not quite nothing. In the final stages, the universe approaches heat death, a state where energy is evenly spread, where no region is hotter than another, where no process can extract work because there are no gradients left to exploit. Time does not stop, but nothing happens. This is the edge of time, not because time ends, but because time becomes meaningless. There are still particles, still space, still laws of physics, but nothing changes in a way that matters. No stars ignite, no structures form, no observers emerge. The universe does not end with a bang. It ends with no audience. This vision is unsettling not because it is violent, but because it is indifferent. The universe does not punish itself. It does not collapse under its own weight. It simply relaxes into uniformity. The cosmic story does not conclude. It dissipates. And here, something deeply human intrudes. We cannot help but project finality onto heat death. We call it an end because we measure existence by activity, by novelty, by change. But from the universe's perspective, heat death is not an ending, it is a stable configuration. Nothing prohibits time from continuing forever in this state. There is no physical law that demands a curtain fall. The universe may persist eternally in quiet equilibrium, unchanging, unobserved, complete in a way that feels hollow to minds evolved to seek motion. This reframes the idea of an edge yet again. If the universe has a temporal edge, it is not a moment where reality stops. It is a moment where difference stops, where the conditions necessary for meaning, contrast, complexity, memory can no longer arise. The edge is not where time ends. It is where experience ends. And this realization has a strange consequence. If the future is an endless, empty plateau, then the present, the era of stars, galaxies, chemistry, thought, is rare. Not just precious, rare. We exist in a narrow window between two hot beginnings and two cold endings, between explosive birth and quiet exhaustion. This window is not guaranteed. It is contingent. Suddenly, the question of the edge becomes intimate. The edge of the universe is not only about distant space or distant time. It is about how long complexity is allowed to exist at all. Life is not a default feature of reality. It is a temporary rebellion against entropy. And yet despite this, the universe does not feel hostile. It simply follows its rules. Entropy is not a villain. It is a consequence of possibility. Without entropy, nothing could ever happen. Without imbalance, there would have been no stars, no planets, no minds asking questions in the dark. The same principle that guarantees the universe's eventual quiet also made its current richness inevitable. Creation and dissolution are not opposites, they are phases. But there is a final unsettling thought. If time stretches infinitely into a state where nothing happens, if space continues without edge, if universes multiply without interaction, then where exactly does meaning live? Is meaning something the universe generates, or something consciousness imposes temporarily, like light cast on a wall that eventually fades? This brings us to the most delicate edge of all. Not spatial, not temporal, but cognitive, the boundary where explanation meets experience, where physics gives way to awareness. In the next part, we will step away from stars and equations and turn inward toward the role of observers in a universe that may not care whether it is observed at all. Because perhaps the edge we have been circling all along is us. The edge as a limit of measurement, where physics itself stops making sense. There is a quiet moment in every serious investigation when the tools stop working. Not because they are broken, not because they were used incorrectly, but because they have reached the boundary of what they were ever capable of revealing. This is the most uncomfortable edge of all. Not an edge of space, not an edge of time, but an edge of description. Physics is often mistaken for a catalogue of answers. In reality, it is a discipline of questions that survives scrutiny. It advances not by declaring truth, but by narrowing uncertainty, by carving reality into shapes that mathematics can hold. And for centuries, this approach worked astonishingly well. Motion yielded to Newton. Energy bowed to thermodynamics. Space and time fused under Einstein. Matter dissolved into quantum fields. Each step expanded the territory of the explainable. Each step made the universe feel smaller. Then the equations began to misbehave. In places of extreme curvature inside black holes, at the first instance of the Big Bang, at the Planck scale, our most successful theories refuse to cooperate. General relativity predicts infinities. Quantum mechanics predicts probabilities without geometry. Together, they produce contradictions, not paradoxes to be solved later, but signals that the language itself is failing. Consider the beginning of the universe. The Big Bang is not an explosion in space. It is the moment when space itself becomes meaningful, when our equations are run backward. Density and temperature rise without bound until they diverge to infinity. Infinity is not a physical quantity. It is a confession. It tells us the theory has exceeded its jurisdiction. At that moment where time begins, where length shrinks to nothing, physics does not describe reality. It points at it and falls silent. This silence is not ignorance in the casual sense. It is structural. Our instruments cannot probe scales smaller than a certain limit without requiring energies that collapse space-time itself. Our measurements disturb what they attempt to measure. Our definitions of before, after, location, causation lose coherence. The universe does not hide its deepest layers behind a curtain. It dissolves the stage. Black holes offer the same lesson. From the outside, they are precise objects: mass, charge, spin, clean, mathematical, predictable. But inside the event horizon, our concepts unravel. Time becomes space-like. Space becomes time-like. Trajectories point inward regardless of choice. At the singularity, the equations diverge again. Not because the universe becomes chaotic, but because our descriptions no longer apply. This is where the edge becomes unavoidable, not as a place, but as a realization that the universe may contain regions where explanation, not observation, not imagination, but explanation itself ceases to function. And this is deeply unsettling, because explanation is how we orient ourselves. We often imagine that with enough data, enough intelligence, enough patience, everything becomes knowable. The universe disagrees. It allows knowledge but not omniscience. It allows precision but not totality. It allows models but not closure. This forces a subtle reframing of the original question. What happens at the edge of the universe? Perhaps nothing happens there. Perhaps what happens is that the question stops being meaningful. Not because the universe ends, but because the categories we use to ask about it dissolve. This is not a retreat into mysticism. It is a recognition of scope. Physics is not the universe. It is a map. And maps do not fail when they omit territory beyond their scale. They fail only when we mistake them for the territory itself. There is a temptation at this point to declare defeat, to say that if the deepest questions are unanswerable, then curiosity has reached a dead end. But that would misunderstand what curiosity is for. Curiosity is not a hunger for final answers. It is a sensitivity to mystery. The edge of measurement does not mark the end of inquiry. It marks a shift in its character, from prediction to interpretation, from control to contemplation, from certainty to humility. The universe does not close its doors. It changes the conversation. And now, something even stranger emerges. If there are limits to measurement, if physics cannot fully describe reality, if the universe is larger than explanation, then what role does the observer play? What does it mean that the universe is being experienced at all? Because every equation we write, every horizon we define, every limit we encounter is filtered through a mind that is itself a physical process inside the universe, a mind that obeys the same laws it attempts to describe. This creates a loop. The universe studies itself through us, and in that loop, a new edge appears. Not in space, not in time, but at the boundary between matter and meaning. Epilogue: there was never an edge. What the question reveals about us: in the end, the universe does something unexpected. It does not reveal a wall. It does not unveil a boundary. It does not grant us the comfort of a final line we can point to and say, here, this is where it stops. Instead, it leaves us here, asking. We began with a simple question, one that feels spatial, almost naive. What happens at the edge of the universe? It sounds like a destination, a place you might approach slowly, with better instruments, sharper equations, longer patience, a cliff at the far end of reality, where something definitive waits. But after all the horizons, all the expansions, all the infinities and quiet endings, one truth remains. The universe does not appear to be built with edges, at least not the kind we can stand beside. Every edge we chased dissolved into something else. The edge of space became a horizon of light. The edge of distance became a limit of time. The edge of expansion erased the idea of center. The edge of infinity denied finality. The edge of the multiverse multiplied reality instead of ending it. The edge of time faded into entropy rather than collapse. The edge of physics became silence, not revelation. Again and again, the universe refused to behave like a container. It behaved like a process. And processes do not end cleanly. They transform, they stretch, they outgrow the metaphors that once held them. The universe is not a book with a last page. It is a sentence that keeps revising itself as it is spoken. This realization can feel unsatisfying at first. We want endings. We want closure. We want the reassurance that somewhere, far away or far ahead, the story resolves into clarity. But perhaps that desire says more about us than about the cosmos. We are creatures shaped by boundaries. Skin separates us from the world. Land separates sea from sky. Beginnings and endings give our lives narrative shape. Edges make meaning manageable. So we project them outward onto space, onto time, onto existence itself, hoping the universe will reflect our need for structure back to us. It doesn't, and that is not cruelty. It is honesty, because the universe was never obligated to be intuitive. It was never obligated to be comprehensible in total. It was never obligated to resolve into a shape that fits inside the human mind. The fact that we understand any of it is already astonishing. There is another way to look at this. Perhaps the universe has no edge because it was never meant to be an object we stand outside of. Perhaps it is not something we are meant to finish understanding. Perhaps understanding itself is a local phenomenon like stars, like life, something that emerges briefly in pockets, burns brightly, and then fades. Meaning, then, is not universal. It is situational. This does not diminish it. It makes it precious. The fact that the universe may stretch infinitely, loop silently, or multiply beyond observation does not erase the significance of this moment of thought occurring inside matter, of awareness reflecting on the whole that produced it. If anything, it sharpens it. The universe may not care whether it is observed, but observation happens anyway, through us, through fragile arrangements of atoms that, for a short while, can wonder. That can ask questions with no guarantee of answers. That can stand at the apparent edge of understanding and keep looking, not because certainty waits beyond, but because looking is what we do. And here is the quiet inversion at the heart of the question. When we ask, what happens at the edge of the universe? We are not really asking about the universe. We are asking whether there is a limit to meaning, whether there is a final context that makes everything else make sense, whether existence itself resolves into explanation. The universe's answer, if it can be called that, is gentle but firm. There may be no such place. There may be no final vantage point where everything aligns, no ultimate frame where confusion disappears, no edge where mystery stops. And that does not mean the universe is empty. It means it is open. In that openness, we find our role, not as conquerors of cosmic territory, not as owners of truth, but as participants in an unfinished story. We do not reach the edge of the universe. We reach the edge of our models, the edge of our language, the edge of our certainty, and then we build better ones. The universe does not end. It does not explain itself. It does not wait. It simply continues expanding, cooling, transforming, while small islands of awareness flare briefly within it, asking questions that have no final answers. That is not tragedy. That is context. So if you ever find yourself staring at the night sky, wondering where it all stops, remember this. There may be no edge out there, but there is an edge here. In the moment where curiosity meets humility, where knowledge meets wonder, where the universe becomes not a thing to finish, but a place to belong. And perhaps that was the point all along.